Okay, so let's jump straight into a simple example of passing some raw Json into highly optimized Parquet format to query on the AWS Athena data lake. So if I click Connect Data Source, you can see there's a series of data sources supported here, some basic ones that are just free to use. You can sign up online and have a go with these, and then we've got some more advanced integrations for streaming and batch loading. So I'm just going to upload a file, and I'll show you the contents. It's very simple. There's just one record in it, but it's a nice example of a piece of raw JSON. You can see that it has a nested data structure, so there's an enclosing array with the object itself, which represents a customer, some customer attributes, and then a sub-nested element which contains the name field. So we'll upload that file, and I'll just call this ingest job customer. And if we save that, Skippr's now analysing that raw data. There's only one record, but there might as well be billions. It doesn't make any difference to Skippr. You can see that it's passed any validation errors, discovered the schema, and here we have our nested representation of that data. And just to remind ourselves, there's the raw data. We have customer, which is a nested record of some attributes, and then within that we have another, again, that nested map of name. So we might decide at this point, while Skippr is purely a loading tool and doesn't really make any attempt to transform data, that's for other platforms, we may at this point be interested to note that actually there's some personal identifiable information in this, and so it's entirely possible we might say for phone actually and email we want to drop those fields. We don't want to load them into our data lake. You could argue address as well, but I'll leave it there for the sake of demonstration. Equally, an entire nested array structure, it's possible we wouldn't want any of these fields, and so we could drop the entire nested structure. In this case, by way of example, I'll just hide the last name field. So if I go ahead and just mask that, and we're okay with that, so we'll save our schema. And the final step is to simply just add an output destination. And in this example, we're going to use AWS Athena. So we'll create a new destination and we'll call that customers. And I'm just going to name the work group customers, which is just the Athena workgroup where our queries operate in. The database I'll name customers, and for the sake of simplicity I'll just name the glue table customers as well, or customer rather. The bucket that we're going to land the output data in, I'll use our test bucket. And rather unimaginatively, I'll save it in the output path of customer as well. The region for this test bucket happens to be in Europe, and then in this case again just my test credentials, and we're set. So we'll test to make sure we've got all that right. Yeah, we have permissions and we've entered the details, and so if we just save that, that's it. That job's now started. So we're now, it hasn't started, apologies. Now it's started. So Skippr's now running. It's passing the data that we've uploaded via that file, which in this case is just that one record. But if you can well imagine, if that was a Kafka connector, you might have billions of records streaming in now. Skippr's discovered the schema, so it's now serializing that data into Parquet format in this case, and outputting it into an S3 bucket, which we can then query via the AWS Athena service. And just to show you that S3 bucket, you might recall that we entered Skippr sample data output. You can see this bucket is currently empty. It's still empty. I've got it configured to output the Parquet data in 1 minute batches. You'd probably want to increase that in production to something like 30 minutes, an hour, what depends on your tolerance. The larger the time period, the larger the files. Parquet files that you'll have output to S3, and that's going to help optimize your query performance. But in this case, we just want a fairly quick result. So in about a minute's time, our data will appear here. While we're waiting for that, we can jump into Athena. This is the AWS Athena console. We see it's empty. If I just refresh, we can see that our customer database and our customer table has been created. And if I expand that, there's our schema. We'll have just a quick closer look at the schema using the generate DDL command. And we can see here we've got an internal timestamp that Skippr has added, and we have our customer record, which is a struct and contains our address, phone, email, company, and then finally the name field, which again is structured data. So not much fun to create these schemas manually. I don't know anybody who enjoys it. I certainly don't. So it's quite nice that Skippr just does this for us, having passed the raw data. So let's pop back to our S3 bucket and see if our Parquet data has appeared. Yep, there we go. Okay, so we output to the customer folder, and we have some time partitioning, which in this case isn't relevant. And finally our Parquet file here, which is just the 2.1 kilobytes. You'd normally expect this to be 100 meg or so, which again would optimize your query. But for the purposes of demonstration, we've just got the one record in here. So let's prove that we can query out this Parquet file via Athena. And we can do that very simply just by saying preview table. And there it is, our one result. And you might recall that we said we were going to drop the name and email field, and the last name we were going to mask. And if I just go back to remind you, there's our drop phone and email and masking the last name. So let's have a look at what it's like to query structured data in Athena. We have a customer record, and let's have a look at the address. And we could equally say, well, we want to check out the name, which is a map of first and last name. And then finally, let's have a look at the hashed last name. And there we are. So this will work with gigabytes, terabytes of raw Json data, all passed neatly into Parquet columnar stores. You can see that the nested data the schema is discovered, and it's all passed out to Parquet nested data structure. So no flattening of JSON and chunking through long JSON strings. It all takes advantage of the performance that comes with the Parquet format and any data lake engine that can take advantage of that format, be it AWS Athena in this case, or Snowflake, or your poison of choice. So I hope that was interesting and useful. Thanks ever so much for checking out Skippr. If you'd like to try it for yourself, just sign up to the beta at skippr.io. And please feel free to reach out via the chat or hit me up on LinkedIn if you'd like to discuss how Skippr can accelerate your data project's time to value.